Hello everyone, this is Atreya and welcome to our channel Code Chef. Today we're going to be solving the problem Deputy and Chef with a difficulty level of simple. So let's get started. Here is written that the battle is raging in the kingdom and there are n soldiers and they are numbered from 1 to n and they are standing in a circle. So since they are standing in a circle, let me take a simple case of n equal to 4 and suggest there are 4 soldiers here and they are standing in a circle like this. This is a circle they are standing in. Now we know that they are numbered from 1 to n, so let's just say this is soldier 1, soldier 2, soldier 3 and soldier 4. It's written that for each valid I from 1 to n, the soldier directly to the right of the ith soldier is I plus 1. This is evident here because to the right of 1 you have I plus 1 which is 2, to the right of 2 you have I plus 1 soldier who is 3, to the right of 3 you have I plus 1 soldier which is 4, and since 4 is the last soldier, to the right of the last soldier you have the first soldier because you're standing in a circle. That's why it's written specifically that to the right of the end soldier you have soldier 1. So to reiterate, to the right of 1 I have 2, to the right of 2 I have 3, to the right of 3 I have 4, and to the right of 4, because 4 is the last soldier, I have 1 again because this wraparound structure of a circle. Now each soldier has a sword and he also has a shield here, and we are given the attack and the defense value of each one of the n soldiers. So in this simple case when n equal to 4, we are given 4 attack values and 4 defense values where ai and di correspond. For example, if this is a1 and d1, this is corresponding to the attack and the defense value of the ith soldier. This is for the second soldier, this is for the third soldier, this is for the fourth soldier, so on and so forth to the n soldier. Here in the simple case we have only 1 to 4. Now in the battle, each soldier picks up the soldier standing to his left or to his right or both, and he suddenly decides to attack them. Now, the choices of the soldiers are independent, and each soldier can be attacked either by the soldier on his left or to the soldier on his right, or both of them if he's unlucky. In case both of them attack that poor soldier in the middle, then that soldier, the attack value will be the sum of the sword value of the both soldiers. So if you're like this, if you're the third person, right, you can be attacked by the person on your left, or you can be attacked by the person on your right, or you can be attacked by both of them. Now in the worst case where both of them decide to attack you, the person on your left decides to attack you, person on your right also decides to attack you, then the attack value will be the sum of ai a2. Let's say this is a2 and this is a4, corresponding to the attack value of the second soldier and the attack value of the fourth soldier. If both of them decide to attack, the combined attack force is nothing but a2 plus a4, which is a combined attack value of both of those soldiers. If only a2 attacks, his attack value will be a2. If only soldier 4 attacks, his attack value will be a4. But in the worst case, where the poor guy is attacked by both of them, the attack value will be a2 plus a4, the combined attack values. That's what is given here. If both of them attack, then the power of the resulting attack is the sum of the attack values of the soldier's suits. Now, or nobody decides. In the best case, no one decides to attack him. A soldier remains alive if the defense value of his shield is strictly greater than the power with which he is attacked. So, if the defense value of this poor guy is greater than a2 plus a4, if both of them decide to attack, then he survives the attack made by soldier 2 and soldier 4. So, the necessary and sufficient condition for a soldier to survive is if his defense value of his shield is greater than the attack value with which he is attacked. That is the main thing. Now what happens is Chef is a deputy of the king, and we have to help him pick a soldier for the king in such a way that the king receives the best shield. That's why I've highlighted this with the greatest defense value. However, if Chef picks a soldier and soldier does not survive, Chef is thrown. So not a great ideal for him. Now it should be guaranteed that whichever soldier we pick will survive regardless of whatever choice the other soldiers make. So whether in the worst case or the best case scenario, in all the scenarios, our chosen soldier should survive for Chef to, not be thrown. Now, can we help Jeff make the best choice, or whatever soldier we choose is will he die anyways? That is the main goal of the question. Can we choose a soldier such that the king receives a best shield with the maximum defense value, and we give him a soldier who will survive in all of the scenarios? Is it possible? Let's look at it. These are the sample cases where this is A1, A2, A3, A4. This is D1, D2, D3, D4. Where now this denotes the attack values, this is the defense values. There are 4 soldiers standing in a circle. To the right of the 4th soldier, we have the first soldier. To the right of 1 there is 2, to the right of 2 there is 3. There's just like we discussed. Now in the worst case, what exactly happens? In the worst case, every soldier is attacked by a soldier on the left and on the soldier on the right. So let's say soldier 1 is attacked not only by the soldier on his right but also on the soldier on his left. So if soldier 1 is, let me just write like this. This is soldier 1, okay. He is attacked by the person on his left and is attacked by the person on the right. So what is the combined value of the attack? So to the left of 1 we have nothing but n, right? Because it's a circle. This is 1, 2, 3 and 4. This is the approach. To the right of 1 you have 2, to the right of 2 you have 3, to the right of 3 you have 4, to the right of 4 you have 1. So to the left of 1 there is nothing but the fourth soldier. What is the attack value of A4? This is left, this is right, this is A4. And now to the right of 1 there is nothing but the second soldier. This is A2. So if both A4 and A2 or the soldier 4 and soldier 2 decides to attack soldier 1, that is the worst case scenario. So what is A4? A4 is 1. What is A2? A2 is 1. So the combined attack value with which this poor soldier 1 is being attacked is 2. Combined attack value equal to 2. What is the defense value of soldier 1? Defense value of soldier 1 equal to 3. So soldier 1 survives. So soldier, we will have a survivor list here, for example, for this case. Soldier 1 survives in the worst case. That means that there are four cases, right? Either the person on your left attacks you, that is one case. Only the person on your left attacks you, basically, what I'm trying to say. Only the person on the left attacks you, one case. Only the person on the right attacks you, second case. Both left and right attack you, third case. None of them attack you, fourth case. So there are four cases. The worst case scenario is when the person on the left and the person on the right both attack you. That is a worst case scenario. In the worst case scenario, the person on the left, who is the fourth soldier, the person on the right of 1, who is the second soldier, both of them attack. Combined attack value is 1 plus 1, 2. Defense value is 3. So survivor list 1 updated. So 1 is the guy who can survive even the worst case. Now we are looking at soldier 2. For soldier 2, what happens? Let's see, to the left of soldier 2, you have soldier 1. In the worst case, soldier 1 attacks and soldier 3 attacks. Why? Because the worst case always arises when both the person on the left and the person on the right attacks you. So the person on the left of 2 is 1 and the person to the right of 2 is 3. What is A1? A1 is nothing but 1. What is A3? A3 is nothing but 4. Now what is the combined attack value? I'll just write this as combined attack value, CAV, cap. So combined attack value equal to 4 plus 1, that is 5. Now what is the defense value of the second person? Defense value of the second person is 4 if you look at this. Since the attack value is greater than defense value, in the worst case, soldier 2 dies. Since there is a potential scenario where soldier 2 does not make it to the end of the day, soldier 2 will not be part of our survivor list. Our survivor list is specific to those soldiers who will survive in all cases. Now let's move on to soldier 3. For soldier 3, basically, who is on the left of soldier 3? Soldier 2 is to the left of soldier 3. Who's to the right of soldier 3? Soldier 4. So now what is A2 plus A4, which is the combined attack value? So to the left of soldier 3 is A2. So what is A2's attack value? 1. To the right of soldier 3 there is A4. And what is the attack value of A4? A4 is 1. So the combined attack value is nothing but 1 plus 1, that is 2. What is the defense value of soldier 3? Defense value of soldier 3 is nothing but 2. So if we look again at the sample case, it says that here, if the defense value, basically the survival condition here, where I was looking for it. So a soldier remains alive if the defense value should be strictly greater than the power with which he is attacked. So in this case, we have the attack value, combined attack value as 2, defense value is 2. Now this guy doesn't survive in this scenario because they're equal. For him to survive, the defense value of his shield should be strictly greater than the combined attack value. So now let's look at soldier 4. Now soldier 4, to the left of soldier 4, that is soldier 3, and to the right of soldier 4, you look at this, soldier 1 is to the right. So what is A3? A3 is nothing but attack value 3, which is 4. So combined attack value will be 4 plus what is A1? A1 is nothing but 1 here. So A1 is nothing but 1 and combined attack value is 5. What is the defense value for the fourth guy? Defense value is 1. So combined attack value much greater than defense value. So there is a scenario where soldier 4 does not make it. So our survivor list is only 1. So only one soldier is there who will survive in all scenarios. So since only one survivor is there, we will immediately say that this is our answer. Survivor 1 is our chosen soldier for the king who will survive in all cases. Now the output is 3 in this particular case because there is only one soldier in our list. Now if we continue and we want to find out, basically this in this particular first test case there was only one survivor. There could be potential test cases where more than one survivor exists. If there exists more than one survivor soldiers who will survive in all of our given cases, we are supposed to only output the soldier in our survivor list with the maximum defense value. That is very important. That's why I highlighted this in our explanation. If there are multiple soldiers who survive in all scenarios, we need to output the value of the greatest defense value over all those soldiers. Hope that part is clear. Now in this part, I suggest you to take any soldier. Now, let's say we take the soldier. This is soldier 1, soldier 2, soldier 3, soldier 4, 5, 6, and 7. Let's say we take soldier 6. Now 6 can be attacked by 5 and 7. So 5 plus 5, in the worst case, the attack value with which soldier 6 is attacked is combined attack value equal to 10, which is 5 plus 5. The defense value of 6 is 5. So since the attack value is much greater than defense value, there is a scenario where soldier 6 dies. So I suggest you to pause this video and take a few example cases, and no matter what example case you take, always there is the case where all of these soldiers will die in any scenario. So whatever soldier we pick, for example, let me take another case. I'm picking soldier 3. In the worst case, soldier 3 will be attacked by soldier 2 and soldier 4. 4 plus 4 is 8. Defense value of soldier 3 is 4. 8 greater than 4. So there's a scenario where this guy dies. No matter what soldier you pick, there is always a scenario where this guy dies. So in this second test case, the output will be -1. Because we cannot pick any soldier who will survive. So the output is -1 in that case. What is our approach? Basically, our approach will be we will loop from 1 to n. Basically, we are processing soldier by soldier. What is the worst case? What is the worst case that can happen? The worst case is the person on the left and the person on the right, both of them attack you. That is the worst case that can happen out of the 4 possibilities we discussed. If both the person on the left and the person on the right attack you. Basically, what we will check is if the defense value of my particular I is greater than my attack value of basically I minus 1 and the attack value of I plus 1. This means that my particular soldier survives. The ith soldier survives when this condition is met. What is this condition? If the defense value of his shield is greater than the combined attack value in the worst case. Combined attack value in worst case, I mean to say, worst case happens when the left guy and the right guy both attack you. Now, if that defense value is greater than the combined attack value, soldier I survives. So we will say max equal to, because that is not our condition. We don't want to find any soldier who just survives an output. Out of all the soldiers who survive in the best case, we need to find out the maximum defense value. So we will say, let's say max def. We will have this max defense value equal to max defense value and defense of I. So why are we doing this and not just breaking out since we found a soldier I who survives? We are doing this because out of all the soldiers who survive in the worst possible scenarios, we want to output the soldier with the maximum defense value. So we have a variable max def for that purpose, and we are going to say max def equal to max of max def and defense of I over all soldiers I who survive. Now you might say, hey, like for I equal to 1, I equal to n, shouldn't you handle I minus 1, I plus 1 separately? Which is correct. If my I equal to n, then my I plus 1 should wrap around to 1. If my I equal to n, because to the right of the n soldier, there is a first soldier. There is no n plus 1 soldier. There is a first soldier again. And it needs to wrap around. And I also need to handle that if I am at my first soldier, I minus 1 is not 0 in this case, but it should wrap around to n. Remember the circle structure 1, 2, 3, 4. For my first soldier, to the left of it, I have my n soldier. For my n soldier, to the right of him, I have my ith soldier. So these are the two simple conditions I need to handle. This was the main approach, and hope this was. Let us do the approach that we have just discussed. In this approach, we are inputting n, and then we input the attack and the defense value for each of the n soldiers. We are using one based indexing here. And then after that, what we are going to do is we are going to do the worst case scenario. We're going to process for each soldier. For each soldier, the worst case scenario is if he's attacked by the person on the left and by the person on the right. So we check if the defense of that particular ith soldier is greater than the combined attack value of the left attacker and the right attacker, then that ith soldier survives. Over all the soldiers who survive, we need to find the maximum defense value. So we do this. Now here you might ask where you handle the condition boundary cases. We handle that here using the ternary condition. If my I minus 1 equal to 0, which means that I am at the first soldier, then to the left of my first soldier, I will have my nth soldier. Similarly, if my right attacker equal to n, which means n plus 1, which means that I equal to n. When will I plus 1 be equal to n plus 1? Only when my I equal to n. If my I equal to n, I am at my last soldier, and to the right of my last soldier, I have 1. Otherwise, it's I plus 1. So this is handled here. So now once I have my value of left and right attacker, it suffices to check if the defense value of the ith soldier is greater than the combined value of the left attacker and the right attacker. Now if my defense value is greater, I survives. If the soldier I survives, we use max defense of I, and over all the soldiers I who such survive in the worst cases, we are going to output the maximum defense value. So we output answer. Hope that part is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.